Oops, I'm not recording. Now I'm recording. So I just need to go back up here. Sorry, I wasn't recording. If you guys need to hit pause, you can hit pause and write that down. Sorry about that. I'm recording now though. Okay, so what we're going to do is we're going to take a visual look of what that meant there. Okay, so there's lots of different cases that can happen. So the first basic case is we have a side and an angle. Okay, so we have angle A, we have side B, and then I'm going to try to make this as colorful as we can. This point right here is a pivot. Now, when I mean a pivot you can also think of like a hinge. Okay, so like on a doorway, right, the hinges allow it to rotate. So remember, it's angle, side, and then side. Okay, so remember we're looking at angle, side, side. So an angle, side, side means we're given an angle, and then we have a side here and a side here. Okay, and we don't know the angle in between these two sides. Since we don't know the angle in between these two sides, this becomes a pivot. And a pivot just means is that we can take this side A and we can rotate this side A. Can you guys imagine just taking grab of this side A and then rotating it? Okay, so the pivot is a point of rotation. Okay, and what we want to do is we want to find the height of this triangle. Okay, now in this case, so I'm going to look at situations. We're looking at, okay, given the situation, what's going to happen? So in this situation, right, again, all of these are going to be angle, side, side. Notice how A is shorter than the height. That is, A is less than H. Okay, so if A is less than H, so if I swing this, so can you guys imagine putting a strobe light on this? And if I swung this, it would look like this. Right? Do you guys see how the blue is the path, right? Where if I swung side A, that's the path it would take. Well, notice how this path never makes this a triangle. Okay? So if I swing this back and forth, A never makes contact with this far side, and it would never make a triangle. So there is no solutions here. As in, there's no triangle. Okay, so if the side A is less than the height, then there's no solution. There's no triangle. So again, we're going to have to find the height from the pivot and compare that with side A and side B to see how many solutions we have. So right off the bat, if your side A, and right, we're calling side A being across from this angle that's given, then we can't have a triangle there. And feel free, guys, to ask me questions as we go through that. So that's our first scenario. Okay, so the first scenario is A is less than H. The next scenario is, okay, again, all of these triangles are going to have the same start, right? So we're going to have an angle A, a side B, we're going to have a pivot. But now, what if, I'm going to try to draw this correctly. We have a height. So now, what if this is exactly the height of H? So then we can see if this side A swings down right here, we're going to have exactly one triangle. And that's because A equals H, right? So if A equals H, okay, then what kind of triangle we're going to have? We're going to have a right triangle. So this then would be called one solution. And it is a right triangle. If in geometry your teacher told you about HL as a way to prove triangles congruent. HL, hypotenuse leg, that is this solution of ASS triangles. Okay. How are we doing so far, guys? Does this make sense what we're talking about? Right? So what we're looking for to solve these kind of triangles, we're going to have to find the height, and we're going to have to compare it with the sides, right? So that's what we're going for. And does it make sense with the swinging? Does it make sense with the amount of triangles we can get? Right? So if A is too short, it's not going to make a triangle. If A is the exact same height, okay, then it is going to be just one triangle. Does that make sense? Are people doing okay with that? Okay, I just want to make sure. And as always, if you guys need me to explain something a little bit better, go ahead and just ask, right? I'm going this. The lesson, this is 6.1, day 2, solving the ambiguous case. Okay. All right, so then next up, okay, well, we're having the same thing here. So we're gonna have, we have angle A, we have side B, we're gonna have a pivot, and then what happens if A is really long? Okay, so if A is really long, okay, so notice here, A is longer than both H and B, okay? So in this case, how many triangles do we get? We're just gonna get one triangle. So what is this? This is A is greater than or equal to B. Okay, because if it was equal to B, right, it would just be, if you swung it over, it would just be a line, right? It would just be a segment because A and B would overlap. So if A is longer than B or the same length as B, then we're only going to have one solution. Okay, and that's what's going to happen there. So this is one solution. Okay, so one solution, one triangle. Notice how this angle up top here is going to be obtuse. Okay, so where the pivot is going to be obtuse. Okay, and then one more, and then we're going to drop down to another line here. So again, the same start. We're going to have angle A, side B, and that goes up to a pivot, right? And the reason why we always have a pivot, right, is because it's angle, side, side, so we don't know the angle in between the two sides. And then here, A is going to be, oh, this is going to be hard to draw this second. Let's see if I can do this right. So A is going to be less than B, but greater than H. And what happens here is you get one triangle here, but then when it comes up, you get a second triangle here. So there's two places where it touches down. So that means we can have a small triangle like this, or we can have a larger triangle like this. So this is tricky because you can have two solutions. Okay, that is two triangles. Okay, so when A is less than B or greater than H. Now, I want you guys to know I don't memorize this stuff. So everything that I'm writing here, where it's like A is less than H or equal or it's less than, I don't memorize this. I literally draw a picture. I figure out what H is, I figure out what A is, and then I just draw this picture. And I'm just like, okay, it's this length. If I swung it, how many times would it give me a triangle? Okay, and so I want you guys to know the picture is what I do. I don't memorize any of this because none of this is important enough for me to memorize in my brain. Okay, so I want to make that really clear. I don't have this memorized. Okay, if you quiz this on me, I would be drawing a picture every time. Okay, and I'll do that when I do my examples. Okay, now all of these are when angle A is acute. And we talked about this a little last time. Remember how I said you always want to find the biggest angle first? We always want to find the biggest angle first because there's restrictions with sine. And so when A is acute, that's not a big deal for us because if A is acute, it's not necessarily the biggest angle. Okay? Now, if A is acute, it still could be the biggest angle, but it's not going to be the biggest issue. So now let's close this off. Okay, what happens if A is obtuse? Okay, well, if angle A is obtuse, that changes things. It changes dynamics. And again, I don't memorize any of this stuff. So I'll show you how I do it in my thing. All you have to remember is biggest angle comes first. Okay, I feel like cavemen. Biggest angle is the best angle. Okay, so if A is obtuse, then, right, so here's, oops, should make it relatively straight. So angle A is obtuse. Then we have side B. The pivot is still up here, right? The pivot is still up. So we have angle A, we have side B off angle A. So now, if side A is small, so right, if A is less than or equal to B, then you can see what happens when you try to swing it, right? We're not going to get a triangle, right? We don't intersect this side down here. So no solution. Okay, oops, was doing this blue. No triangle. Again, I don't memorize this A less than B stuff. I am always just going to sketch a quick sketch and just be like, hey, how many times does it do that? Now, does that mean that your picture has to be relatively accurate? Yes, it does. Okay, so you have to make sure if B is longer, then B is longer. Okay, so it does take a little bit of practice, but then you never have to memorize. And I can tell you right now, I don't get these problems wrong with my method. Okay, now the other version of this is, again, A is obtuse. Okay, and then you have side B, and that goes to a pivot. Okay, and then side A is maybe freakishly long. Okay, and then the whole point here is that it's going to touch once. So that means one solution, one triangle. So again, it doesn't seem like too big of a deal when A is obtuse, but the point I'm trying to make is if you don't start with the largest angle, your calculator will lie to you. And if your calculator lies to you, then everything else that you solve for will be wrong. Okay? Biggest angle is best angle. So we're going to you have to find the biggest angle, biggest side first. And the reason why I say that, so it's not too big of a deal here, but when you have two solutions, there's going to be a biggest angle, and we do the biggest angle first. Okay, we do the biggest angle first. So you're like, crap, you just made us take down all these notes, and then you tell us that we don't need them. Okay, well, I'm right, because I'm the teacher, and I planned this lesson. What's really important is being able to draw a semi-accurate picture and to use this swinging idea to just visually see how many solutions you're going to have. Okay, so hopefully I'm going to use the rest of this period to do 1, 2, 3, 4 problems, and then you guys will be able to practice our homework tomorrow. Okay. Oh, I always worry about you guys because it's like teaching zombies. You guys doing okay? Brains. Okay, you guys are doing good. All right. So let's do a couple of examples. I think, a lot of the times it's just like, let's get our hands dirty. Let's make pancakes. Okay. What's the worst that can go wrong? Well, as someone who's made a lot of pancakes in my life, I can tell you there's some bad things that can go wrong. All right. So, let's do this. Okay. So, let's say I got to have angle, side, and then side. So I'm going to have, this is 12 inches, this is 42 inches, and then this is 22 inches. So I didn't draw this correctly, but you see how 12 inches is a lot less than 12 inches? So I'm going to go and make this longer. Okay. So I might ask how many solutions this has. So to do this, what we're going to do, just like we did at the very beginning of this, we're going to find the height from the pivot. Remember, the pivot is the side in between the two given sides. We don't know this angle. That angle can be anything. So we're going to find the height. We're going to find the height, and we're going to compare that and see how many solutions we have. Now, if you go by how I drew it, right, it's going to be one solution, but we got to check h. Okay, so we're going to solve for the height. Okay, we're going to solve for the height. So remember, we're talking about law of sines here, right? So solving this is really easy. See this small triangle we just created? Then we know that sine of 42 degrees equals h over 12. Okay, and it's really that easy. And once you do a couple of these, you can even skip this first setup because you can just see, well, h is going to be 12 times 42, sine of 42. Okay, so you get your trusty steed and you say, onward, stallion. And remember, if you don't say onward, stallion, you could do this wrong. So it's really important, especially if you're at school, that you say really loudly, onward, steed. Okay. So I get 12 sine of 42 degrees. And make sure you're in degrees, right? We got to be in degrees. So I get the height is approximately 8.03. Okay, so that's approximately my height. So let's take a look at this. If this is approximately 8.03, then when I go like this, it's going to be longer. Do you see how 22 is longer than this? So it's going to be down here. And 22 is longer than 12. So that means I'm going to have one solution. Okay. And that's what I mean. So again, you put the little ding bong here. You know that, right? So this, it's longer. And this, it's longer. That's all I'm checking for, right? So I know that 22 is longer than 8.03, so it's going to go underneath it, and it's longer than 12. So there's only going to be one triangle. So there's one solution. Okay? Now, if you guys recognize these numbers, we did this problem yesterday. So yesterday, what I had you guys do is find all the missing pieces. So that's what's going to happen next. But we've already solved this problem, so we're going to skip it. So it's going to say how many solutions. So that's what you first do. Then your next step is solve the triangle. Okay. So it's not that these problems are difficult. They're just really long. Because you first have to figure out is, okay, how many triangles? And then you solve that triangle. If it's one triangle, then you do what we did last class. You're just solving that one triangle. If it's no triangles, oh, please, 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 then you're done. because you can't solve it. There's no triangles, right? And that's the one that we all want. That's the one where everyone wins, because as soon as you find there's no triangles, you're done with the problem. Now, what we don't want is when there's two triangles, because then now instead of solving one triangle, you're solving two triangles. Okay, and that's what makes the ambiguous case so assy. Because when you do these problems, you might mutter to yourself, ass. Right? Because you'll have to do two triangles instead of one. So just remember, sometimes you'll get a problem and it will say no triangles and you're done. But then sometimes you'll have to do two. Okay? So it's just what happens. Okay? Does anybody have questions about that? So again, this has one solution. So after doing this, we would go find, right, this missing angle, we'd find this missing angle, and we would find this missing side, right? So there's, for every triangle that you do have, right, so this is one solution, which means one triangle, right? Then you would find the three missing things using law of sines. So does anybody have questions about that? So the new step that we're adding is how many solutions, and remember, you only need to do this with ASS problems, right? This is only an issue with ASS problems. If it's not an ASS problem, then you can just go ahead and solve it as long as you start with the largest side angle, okay? So again, this is only an issue with ASS triangles, okay? Or else you can just go with it as long as you start with the biggest angle first. All right, I'm not hearing anything from anyone, so you guys doing okay? Let's do a full one. Let's do a full one where we see how many solutions and then we solve. Okay? Let's do it. Let's do it. Let's just do it. We're going to do it. It's going to be great. Okay. Example número 2. Okay. Oh, that's mine. I have to do this. Okay. So let's say solve the triangle where A equals 15 feet, B equals 25 feet, and angle A equals 85 degrees. Do it! All right, so what's the first problem we have here? What's our first issue? And it's not just that Kreft is going crazy, though I am going crazy. That's not your issue, though. That's my issue. Actually, it's all of our issues. We're in this together. What's our issue? What do we need? What's missing? Is music missing? Is that what you guys are saying? We need more music? Okay. Maybe you're like, I want Kreft to be black and white. It's more moody. Come on, guys, what's missing? Like, no one's responding. No, we have angles. We have angle A. Gosh, what's that? Ooh, what's missing? We don't have a triangle drawing. There we go. All right. Okay, so let's draw a triangle. Now, notice how we're given two sides and an angle. So this is going to be an ASS. Okay, so the first thing we recognize is this is going to be an ASS. So I know that I'm going to have my angle, 85 degrees. I'm going to have a side. And then I'm going to have a pivot. And I'm going to have, notice how 15 is smaller than 25. So I'm going to draw this side smaller than the other one, right? So it's smaller. So the first thing we have to do, so what did we do? We didn't have a picture, we drew a picture. So no picture, no problem. Draw a picture. Okay? You make it look like how you want it to be, right? Are we good to go? We have angle A is across from side A and B is here. Great. Then we're good to go. Okay? So the next thing we want to do is we got our picture. So now we got to figure out, okay, how many solutions am I going to go with? Okay, we have to find H. You can't just go off your picture, right? Because for there to be a solution here, A's got to be longer than H. You guys see that? So for there to be a solution here, A's got to be either equal to H or longer. So to do this, I'm going to say, okay, sine of 85 degrees equals H over 25, right? So I'm just doing sine using this small triangle. So that is 25 sine of 85 degrees equals H. Onward, my mighty stallion. Okay, and you guys at school, you guys should keep each other honest, right? You should be able to hear each other say that out loud. So keep each other honest. 25 sine of 85. Okay, I hit enter, and I get H is about 24.9. Right, and I'm just approximating it because as you can see here, our side A is not longer, right? So if this is 24.8, right, then it's going to go like this, right? Do you see how it's short? It's short. H is longer, right? It's short. So if it's short, how many triangles do we have here? We have no triangle. So then when it says solve the triangle where, our answer is no solution. Yay! So I bet you guys are all like, you know, after you get done being stared at by your classmates for saying, onward stallion, right? You're going to be like, booyah, I'm done with this problem. I don't have to do any solving. Right? So that's a great problem. This is what we want on the test. This is what we want on our homework, right? Okay. Anybody have questions about that? Do you guys see how we can just use the picture? We don't have to do all that memorizing. Class doesn't work, guys, unless you participate. So you gotta tell me, right? Even like this is the same if we were in person, right? Like I can't read minds. So if I was in person, this would be the same thing. I have to know it. Does this make sense? Are you guys doing okay? What's going on? Yeah. So, right? So this is the side that's swinging, right? And you can think of it as having a little like flasher right here. So we're comparing this, right? So we're comparing A with H with B. So we're comparing A, H, and B, right? So A is the swinging side, right? So A is swinging. So if we take a look, if A is shorter than H, it's never going to meet with this side. It's never going to make a triangle, right? So since it's not even longer than H, I don't even need to compare it to B, right? Because if it's not longer than H, then it's not going anywhere. So thank you for that question. That was a good question. And I really hope more than 2 of you are participating. I'm worried about you guys. Whew. All right. Well, no one's saying anything. This is awkward. You guys, I wouldn't say this is that easy. So the fact that no one is really speaking has me concerned that you guys aren't paying attention. So let's do another one. Really worried about you guys. Am I broadcasting? Are you guys not even hearing me? Because like only 2 students are responding. Are people there? I know you can hear me. You're one of the 2 students that are responding to me. Okay. So there's some other people. So at least 4 of you are listening. That's good. Okay, 5 of you. There's 5 of you paying attention. Thank you, guys. I want you to know that like it's just weird. It's easier to participate now than it is if we were in class. All right, so this example is our dream. This is what we want. So now let's take a look at our nightmare. Okay. So again, let's start here. So we're going to solve the following. we're going to have A equals 12 meters, B equals 31 meters, and angle A is 20.5 degrees. Okay. So let me walk you guys through this. And it's and just a couple things to remember. Remember, biggest angle is best angle. Okay, we always start with the biggest angle. Biggest angle. Okay, you have to start with the biggest angle. Okay, so first things first, we need a picture. We need a picture. So I'm going to start. So I noticed this is an angle. Sorry, I copied this from the book. The book doesn't want to spell ass, so it does SSA. But remember, don't be fooled by SSA. That's just ass backwards. Sorry, I'm choking, but I'm also laughing. Angle side, right? So this is an ass problem. So I'm going to draw a picture. So I have my angle is 20.5. And then I got 12 meters. And then, 31. So B is really long, and then 12 isn't anywhere close to being that long. I do want to make it a little bit longer. There we go. So the first thing we have to do is we have to find the height. Okay, so the height here is going to be sine of 20.5 degrees equals h over 31, which is 31 sine of 20.5. Onward, stallion! So 31 sine of 20.50. And I get 10.8 approximately. So 10.857 equals h, and that's in meters. So interesting. So now let's take a look at what this has to do with. So we know our height is about 10.857. Is anybody getting weird looks at schools yet for the onward stallion piece? No? Just trying to have fun, guys. All right, so if I swing this bad boy, notice how when I get down to here, that 12 is longer than 10.857. So it is longer. So it has to be longer here. Do you guys get that? See how it's longer? Okay, so this has to be longer. But then when I go, 12 is definitely shorter than 31. Right? So it's shorter. Do you guys see how 12 is shorter than this, right? So it's longer than 10.85, so it has to go below the height, but it's shorter than 31, so it has to go above. But what that tells us is that there is how many solutions? There are 2 solutions. So if there's 2 triangles, we have to solve both triangles. Okay, so this is our worst nightmare. So we have to find a total of 6 missing pieces. We have to find the 3 missing pieces for both triangles. So there's going to be 2 triangles. There's going to be this bigger triangle. Do you guys see this bigger triangle right here? Do you guys see that? And then there's going to be this smaller triangle like this. Do you guys see that? So there's the smaller triangle, and then there's the bigger triangle. So what I'm going to do is I'm going to redraw these triangles to help give me ideas. Okay, so I'm going to solve. So one of them is going to look like this. Oops, I went too far. Okay, so this is going to be 20.5. So this is A. This is 31. So this is B. This is angle C. This is 12. and then this is angle B. Okay, so there's one triangle. And then my other triangle is going to be, I have angle A, that's the same, and B, and then C is going to be over there, A. Okay, so this is 20.5, this is 31, this is 12, this is B, C, like that. So these are the two triangles that I got from that experiment. I'm going to hit pause there for a second and see if you guys have questions. Right, so this one on the right, that's where angle A hits before I get to the height. And then the one on the left is when side A is to the left of the height. So we have to find, so in both of these triangles, there's going to be two different angle C's, there's going to be two different angle B's, and there's going to be two different side C's. So again, I'm hitting pause. Does anybody have questions? Does anybody like, Kreft, how did you do this? Thank you, I appreciate you. So I got to get feedback to more than one person, guys. Thank you, guys. And even if it's just simple as like, Kreft, I get it. That way I know that I can move forward, right? Okay. So let's see if you guys remember this. Which one of these should I start? Do I have to start with, and why? The bigger one. So which one's the bigger one? I bet you guys are gonna trip up on this. I knew you would. So I'm getting two different answers. Some people are saying this one, and some people are saying this one. So this triangle on the right is the bigger triangle. But this triangle on the left has the biggest angle. Do you guys see that? In the triangle on the right, angle B is acute. And in the triangle on the left, it is definitely obtuse. So we're going to start with the skinny, if you want to use that word, triangle, because angle B is the biggest. Okay, so we're going to start by solving for angle B in this triangle. Okay. Now, this isn't going to be as big of a deal until we get to law of cosines, but I'm starting you off right off the bat. So to solve for angle B, I'm going to have sine of angle B over side B equals, and then I know A, right, is going to be, did I do this backwards? Oh shoot, I did this backwards, didn't I? Okay, so here's the problem. Which quadrant is our because I just said this, right? What quadrant is my calculator going to give me? It's going to give me the first quadrant, right? So this is going to give me the acute angle, isn't it? It's going to give me the acute angle first. Yeah. So I was wrong. I'm glad I caught myself. When we get to law of cosine, though, I want to do the biggest angles first. I have to do the acute angle first because that's all my calculator will give me. And the reason for that is sine's going to give me an answer in the first quadrant. And the first quadrant are angles between 0 and 90. Notice how this angle will be greater than 90. But when you do sine in your calculator, it's going to give you only an acute one. So I'm going to do sine of angle B over side B equals sine of 20.5 over 12. So to solve this, I'm going to multiply by 31. Onward, stallion! Okay, so I get out my trusty stallion here, and I go sine of 20.5 over 12 times dirty 1. And I get 0.9. Now that's not an angle, because remember, we still haven't gotten, that's for sine of b, right? So if I want b, then I have to take sine inverse of all of this. Okay, so angle B is gonna be, so I take sine inverse of my answer, and I get 64.78 degrees. Okay, because sine will only give you the acute angle. So take a look at our pictures. If sine will only give me the acute angle, that's this angle, because this angle is obviously obtuse. Okay, so this is 64.78 degrees. So we got 2 more things to solve for, right? So the next easiest one is going to be angle C, right? So I'm going to go 180 minus my answer minus 20.5. So I get angle C is 94. So angle C is 94.72 degrees. Right, and I can show my work next to it. Oops, angle C. Okay, so 180 degrees, and then it's really important, guys, that you don't round. So see how I didn't round here? If you round, your answer will be off. So don't round. So you need to have your exact answer. You have to use your calculator. This is a calculator-only activity. So you cannot round. I just want to make that super clear. You cannot round. And then the only other thing that we're missing at this point is side C. So I'm going to have to solve for side C. So side C, it's going to be side C over angle C. So sine of 94.72. Okay, so that, and then equals, and then we can do, let's do A. So side A over sine of 20.5. So how do you do this, right? How do you do this without rounding? So you just go like this. So with your answer still in your calculator, just go into your next one and go, okay, I'm going to have 12 over sine of 20.5, and then times sine, and then do second answer. So this way you're not rounding. We're keeping it all in the family, all in the calculator. Okay, I don't know what that was. That was supposed to be my stallion getting excited. Okay, so I do this, and I get my side C. So little c is 34.15 meters. You guys see how important units are, right? It's not an angle. So there I have found my angle B, my angle C, and my side C. Now, I hope you guys thought this was fun, because now we're going to do everything over here for this triangle. You guys see these problems are long, right? So I'm going to pause just for a second to make sure. Does anybody have questions for how I finished this triangle? No, we're okay? Oh, wow, we're out at 2. So we're not going to get a lot of practice in today. But that's okay. We have each other tomorrow as well. You guys shouldn't be leaving. We're not done with this problem. Okay, so to get over here, how do you start this problem? You start with angle B. Angle B is going to equal this angle B, so 180 minus this angle B. Okay. So what I would even do, because I don't want to round, is I'm just going to do angle B over here again. So I'm going to do sine inverse of sine of 20.5 over 12 times 31, close parenthesis. So that's that. So I can go 180 minus my answer. And then that's what my angle is. So angle B is going to be 115.22 degrees. Okay, so that's how you get the second angle. So once you get the acute version, you can just do 180 minus angle B. I should have here. This should be red. And this should be blue. There we go. Why? So the reason why is if you take a look at these triangles, what do the angles in a triangle add up to? They add up to 180. Now I'm running out of time, so I'm going to have to finish this problem. But what's happening is that these two angles are changing, but this angle is staying the same. So they should still add up to 180. So all you're doing here by rotating through like this, and if we have extra time, I can prove that to you, is the reason that what's going, so that's one way of thinking of it, right? Is I can do a triangle summation proof, or you can think of it as the way that your calculator is working. So if you think about a unit circle, there are two places in which sine will have the same, will have answers, right? So if you look at sine, it will only give you the first quadrant. So if you take, now 180 is pi, so think of a circle, right? So one solution is over here. So if you go across here, if you take 180 minus this solution, then you get your solution in the second quadrant. So I hope that makes sense. People are dropping. I don't understand why people are leaving. This is really poor decision making on people's parts. Okay, but it makes sense because they're also the people that weren't participating. So that's how you get angle B. Does that answer your question? Right? So maybe the unit circle is the best way to think about it, right? So if it's in the first quadrant, you take 180 minus that, you get your answer in the second quadrant because it's the difference. Okay? If you want to talk later about that, we can tomorrow bring it up. So then to find the other ones, right? Angle C, that's going to be 180. So 180 onward stallion minus angle A minus my answer for this one. Oops. So that's going to be 44.28 degrees. So again, how did I do that? This is 180 minus angle A minus angle B. Okay. And then to get side C, I'm going to do side C over sine of my angle. So I got 44.28 equals 12 over sine of 20.5. So just multiply both sides by that. So in my calculator, onward mighty stallion, I'm going to go, oops, and I have to end class here in just a minute. We're going to barely make it. Sine of 20.5 and then times sine of 44. Oops, I can just do the answer because I had it as my last answer. And I get side C. is about 23.92 meters. Okay, and that has solved the problem. So I showed you one example, guys, of a problem being really easy, and then I showed you one problem of it being really difficult. That's it for class.